So, okay, we continue with our session. Our next presenter is Herman Moreira from the Polytechnic School of the University of Sao Paulo in Brazil. He will present the paper number 11 entitled Application of Demand Response on Smart Grids. So now, Mr. Moreira, the floor is yours.
Yes, I'm here. Thank you so much for this presentation. And okay. Can you see my presentation? All right.
Yes, I can see.
Okay. My paper is entitled Applications of Demand Response on Smart Grids, and I'm a first author, Herman Moreira. I'm a PhD student at the University of São Paulo in Brazil, and I'm professor too, and another institution. And the second author is Dr. Nelson Kagan. And this work is about a project that we are developing in our institution, and we have I would like present this model that we are working now. That's right. In this introduction, I would like present to yours that the physical integration between end users of energy or consumers of energy and the power grid operator uh, uh, can provide many facilities and opportunities to restructuring power electric system using technologies like data analytics, big data, IoT devices, cloud computing, and another new technologies. All right, and this is an opportunity to apply at the conventional power electric systems. Our work propose to develop a system that can integrate and prove benefits of logical and physical interconnection, demand response utilities, integrating the concept of smart cities, smart grids, smart demand response, smart building, and smart energy, integrate smart generation and smart end users, right? What the benefits about this? First, we have a more reliability. We have to energy efficiency. We can provide new scenarios of residential and commercial micro generation on prosumers, and available data to use in planning and operation of the grid. That's right. In the figure 3, we have a demonstration or an illustration about this type of integration. At here we have, for example, renewable energies. At here we have a type of storage system that can use batteries or another type of storage. We have diesel generators, and this these renewable energies can be integrated by an inverter, and we can use to electric vehicles to integrate in small consumers or commercial consumers, and we can apply to this model to industrial consumers. That's right. Um, to apply these new technologies like data analytics, cloud computing, IoT devices, for example, big data, we can use microcontrollers to control the end users, right? End users and load into the residential or industrial consumers. This data obtained in this site we can send to cloud computing, right? And with these data we can apply data analytics and obtain load shapes. And these load shapes can be sent to distribution operation centers. With this data and with this analysis, the operating system can use big data techniques to planning and operated the microgrid of the smart grid. This is the main difference between conventional energy systems and new energy systems like smart grids. All right. Well, our background is based on demand response that can use and provide connect objects by internet, remote monitoring of these loads, multi-operation by IoT, adjusting the load curve at here, this figure. We have an adjusting load curve in the period of peak demand and control loads via DR, demand response, all right? And for example, if we have some consumers like residential and commercial, these loads can be controlled about IoT devices. And the smart grid promoted power utilities, new service models, more participation providers in market, distributed generation and energy store integration. That's right. And active management system applied to smart cities. The big data technologies can collect and store data regarding the consumption and generation and energy storage. We can provide with this data mining, analyze and generation, produce profile demand curves, right? Our method is based on intelligent dispatch of energy model developed, right? I study, for example, I study platform of simulations is proposed in another work, this reference 4. And centrally, the intelligent system uses a distribution feeder test with the idea of information from other systems of the energy companies, such as GIS and SCADA, and use of complex calculations of the network, such as state estimation, power flow in small networks, with less than 135 buses, right? In which the calculation of power flow requires less computation cost. Our model was implemented using the air, right, demand response techniques, and the concept of smart grids. And we create a model of platform that was developed to perform an intelligent dispatch integrated prosumers, aggregators, network operators, energy market agents, using a set of possible network planning and operation scenario, as we will see ahead. Well, this figure presents the intelligent dispatch of energy model developed for us. And first, we have at here renewable energies, right, and storage systems, and we have conventional energy resources. This data of this type of energy can be controlled and measure and to measure, and this data will be sent to a hub, like a hub, all right? And this hub will be controlled to IoT devices. And we have, for example, the level of generation about photovoltaic solar photovoltaic energies, wind energies, thermal, hydraulic, and this data will send to this hub. And for example, if you have a power plant or a site and that we have this type of installation of renewable energy, we can control the production of energy. And with data analytics, we can use this data to choose the better local or the better time to dispatch this energy. This all this data will send to cloud computing, and we have a connection with these consumers by IoT devices too. All right, and for example, we can choose the type of prosumers, rural, industrial, commercial, or residential. And if it's possible, we can optimize the dispatch by demand response. We we will proceed this type of control. If not, we will try the conventional dispatch. The next figure show how can it proceed. For example, the method of our intelligent dispatch model, we use direct load control, for example, right? And if you have installed in the residential consumer type of direct control by IoT, we can optimize this dispatch by demand response. If you know, we have a conventional dispatch. The next step is dynamic rating, is about the price of energy. If you have another type of tariff, all right? For example, in Brazil, we have a white tariff. We can dispatch to this energy by direct load control and white tariff, right? And the next step is uh, to simulate the grid if we have a good performance about voltages, about currents that flows by the grid. Okay, and finally, uh, if in the last step we have direct control, white tariff, or dynamic rating, we can optimize the balance sheet and to finally this dispatch, this intelligent dispatch. Well, the optimization proposed method is based in linear programming, right? And first, we can to minimize the use of consumption or purchasing of high cost energy, or to maximize the profit or sale of produced energy, like production or sale, right? The objective function formulation is based on the first cost for acquisition, deployment and return on investment of the power and solution, control technologies, and your restrictions. The second point of our objective function is about the investment in low voltage and medium voltage grids of the power companies and your restriction, including power losses. And the third part of our objective function is the equalization trade-off of operations, building and selling between consumers enjoyed in accordance with performance of the actors involved in the other maximize their earnings to minimize your loss for the execution of the contract based on tariffs. At here in this figure, we have an example for these three parts of objective function. The first part is about to minimize or to maximize, and we have this side, all right, of the optimization. The second side is about the optimized dispatch, like minimization of production, of consumption. The third part is about rating, all right, is like tariffs. And the last one is about the network infra, the availability, the available use of grids. At here we have,
I'm sorry, 2 minutes to finish, please.
okay, thank you. We have an architecture solution proposed, all right, is like a hub that interconnect our prosumers and the grid. We have the input data at here, right? We have a key. We have here data acquisition about network operation center. We have here a microcontroller, and the consumer or prosumer can insert it your demand or your data about a tablet or an app, and here this data is concentrated on cloud computing. We have here an artificial intelligence about a program, and we have the benefits of the model response at here in this last part. Finally, our contributions is involves the logical and physical integration between hardware devices and software applications by IoT and big data. Um, we can use techniques of machine learning, data mining, and analytics, and the model and platform was developed to available visualization and interpretation of the characters of consumption, logic curves, curves of generation, storage, and the timely information for decision making, multivariate analysis. Our focus too is the project involving Industry 4.0 and IoT of Brazilian Ministry of Science and Technology. And another objective is enables the control and acquisition of data in real time for validation routines and simulations that will be dedicated to new features, utilities, and simulation tests of electrical distribution networks with a focus on DR in the form of prototypes at the University of São Paulo, all right? And the proposal model and your test platform contributes to studies on the implementation of new tools and technologies to solve typical problems of automation. In addition, the work proposed application of new technologies integrates the various sectors of electricity supply chain. And finally, the discussion introduced a proposal for innovation to conventional electrical systems by bringing an approach focused on the use of renewable energy sources. I'm thankful for everything. Thank you so much.
Thank you so much, Mr. Moreira. So we will go ahead and take some time for questions. Does anybody have a question? Please write in the chat box.
Sorry, I can understand. Could you repeat, please?
Yeah, we will take some time for questions.
Yeah,
So
I have.
if anybody only 5 minutes or maybe depend the question that people can write in the chat box.
We have a question here in the chat.
Yes.
What is that?
Yeah.
Can I answer?
Yeah, of course. First, I'm going to read the question for all the people that wants to listen. So, what is the advantage for distribution business that can apply demand response?
All right. This discussion is the main discussion about our dam. All right. And for example, we have two sides: the side of consumers and the side of companies. All right. The great opportunity for companies is that the companies can install it renewable energy sources and many local sites of the grid, all right? And the company can use this same controls to operate the grid. For example, if the company have a site and we have a bank of batteries, the company can use energy to storage for the period of intermittence of energy solar, like a period of the day, and the night to dispatch this energy on in the our peak demand, right? And this type of control can provide more a better performance to the grid.
Okay. Yeah. So the next question is, who is going to pay for the infrastructure?
Well. This type of investment first is pay to the prosumer of consumer, but in Brazil and in other countries we have the contribution of the government. All right, we have policies about the government that start these initiatives to renewable energies, to apply renewable energies, like resources in a bank or financement and other types of investments to apply this infrastructure.
Okay. Thank you.
In
Thank you.
resume, in resume, this investment can be public or private.
Okay. Thank you so much, Mr. Leal. So let's continue with our session. Our next presenter is Ismael Sanchez.
Okay.
Okay. Thank you so much. From the
Hello.